Hello, and welcome to Applications for Statistics and Psychology, our first lecture of the semester. I hope you guys are ready to dive in. This first chapter, this first lecture is not nearly as nitty-gritty or as heavy as other chapters. So don't worry yet. We're not going to jump right into the deep. We're going to wade our way in slowly into statistics and the applications of statistics, starting with why should we even care? So let's get started. So let's start with giving you guys an overview about what to expect from this lecture and where we're going over this lecture. Hopefully it's going to be kind of short. So just so you guys know, we're going to start with why care. Why should we even care about stats in the first place? And then the big question I've heard immediately following that one is it hard? Am I able to do this? This sounds like something that only super nerds can understand. And then after we walk our way through those two very important questions, we'll start talking about some of the groundwork that you need to know before jumping into statistics for psychology. So I wanted to start with why do we care about stats right off the bat? Because I have a lot of students who it's important to know why to invest in something before we ever invest, and that's a reasonable expectation. I'm not just going to sit here and demand that you understand formulas without ever telling you why those formulas will matter to you in your life. So for some of us, we care about stats because that's exactly what we want to do. Right? Some of us are scientific in our approach to life and are scientific in our approach to school, and we're in academics for an obvious reason. We want to do research. So for some of us, this question of why do I care about stats is pretty easily answered. But there are some of us that are like, well, actually, I want to be a practitioner, or I want to go into health, or I want to work with people. Why do I care about stats if I'm not doing research? So for those people who may not have such an easy connecting point for what they want out of this class, after this class, and statistics, I wanted to start here and kind of help you guys understand how statistics is something, or at least understanding basic statistics is something that can help you really become a very versatile tool in whatever place of work you end up in the future. So right here on the slide, you can see that the first category, why I think everyone should care about stats, is there are actually huge workplace advantages, right? If your brain can understand how to identify and describe variables and the relationships between two variables, suddenly you have a way of nuancing information on just pretty much any project that's going on in any business. For example, if you're say you're in the HR department of like a kid's gymnastics studio or a kid's karate studio, right? At first you're like, why would that person ever care about statistics or thinking about variables? But if you can think in variables, you can think about like, well, if I understand what makes my employees happy, and I can understand what makes them unhappy, and I can then start to understand how to talk about these variables and how they relate or how one might cover up the other, and then you can start having really interesting ideas on how to solve problems and things like that. So thinking statistically is also a way of thinking about real life problems. And that gives you really strong coherence input that lots of different people can understand, right? Experience with data makes receiving new data much easier in the workplace, makes you more adaptable, right? I hope this isn't the case for everybody, but a large amount of students I've interacted with have had a boss at some point in their life who just didn't keep up with the changing things or the changing atmosphere in the workplace, right? Maybe the boss got used to, like a grocery store boss might always get used to, no, we always buy a huge amount of bread in this month because that's always what sells. We always sell more bread this month, so I'm always going to buy more bread this month to sell more bread this month. Well, if you work with data, and you know how to understand histograms, bar graphs, just changing values, changing variables, suddenly when you receive new data, you know how to adapt more easily. You know how to pivot and mold yourself to the new scenario, the new atmosphere you find yourself in. And adaptability in workplace is incredibly crucial wherever you go, wherever you go. And one thing that I've heard from students in the past is if you have a really good way of understanding data and finding data and understanding variables in the workplace, you can more often say this sentence: I don't know the answer now, but I know how to find out. Right? If a higher up asks you, hey, we have this problem going on with the budget, and some people say it's going to be just fine, and some people say it's not going to be fine. If you understand data to some degree, and you understand how to get data to some degree, then you have the tools not to have the answers now, but how to get answers. And every higher up loves having an employee that knows how to get answers, right? Hey, what's your input on this? What's your input on this? Well, I don't know right now, but I know how to get it to you. That makes you not only hireable, but it also makes you promotable. It makes you able to climb the ladder in most business situations. So even if you don't go and conduct research after this class, which not all of us will, hopefully the way you think will be flexible, stronger, adapted for the workplace in new ways. And the next big thing to care about with stats is everyone uses stats. Everyone uses stats to talk about different beliefs they have, different politics they have, and different people groups and interactions and things like that. I can't tell you the number of just stats that get thrown at a person throughout the day just through advertisements, through social media, through news outlets. But the dirty truth is most of those stats are either faked, they're either misrepresented, or to some degree there's other questions that you can ask that tell you, oh wait, this data actually doesn't matter to the question I'm asking. So why would data be used incorrectly on purpose? Well, it's to manipulate consumers. It's to manipulate voters. It's to manipulate the social atmosphere that we're in, right? So the more you understand about data, the less likely you'll be manipulated by social media, by different advertising firms, different political systems, and sometimes it can be something as benign as, oh, I thought we were going to have enough money to do this new project in the business, but I guess I misinterpreted the data. That's one option. But another one can be as grotesque as real life example. We had an advertisement firm come to our place of business when I was a business manager, and they showed us all of this data about how they could advertise with geolocating and just drop very specific advertisements into people's phones and laptops based on how close they are to our business physically. And it sounds great, right? It sounds awesome. And then some of their data that they showed me, I started asking important questions like, wait. You said you do this advertising, but here, this sounds like we create the ad, we create the artwork, we create the wording, and then we submit it to you who just presses a button and it sends out. Like, we do all the work for advertising, and then you just click one send button. And we're going to pay you $800 a month for that, when I could easily go to Google and do the same thing. So simply understanding how data works kind of prevented us from spending a lot of money, at a minimum of $6,000, on something that would not have actually given us any kind of business. So the more you understand about data, the less likely you are going to be manipulated by data. One of the points I have here is data can be reported in a way to manipulate others, and you'll be less likely to be manipulated. So this household violence, what does that mean? Well, there's a couple of numbers out there that people report very quickly um, without giving the full consensus. And really, it's because they have beliefs behind the data. So they want the data to reaffirm their beliefs without actually, it should be the other way around. Data should tell us about reality. It shouldn't be our reality telling us. We shouldn't be telling data what to say. So household violence, what does that mean? It means if you look at data and you look at who commits more household violence, men or women, broadly speaking, you'll actually find that those numbers are incredibly similar. But if you ask one question, well, what kind of household violence? Suddenly the numbers get very different very quickly, right? There might be verbal abuse that's very similar on both ends of the spectrum. Physical abuse might be similar on both ends of the spectrum, but physical abuse that leads to hospitalizations, physical abuse that leads to permanent damage, those tend to lean towards men, white men, white straight men, by the way. But you would never see that data if you simply asked household violence, right? You have to know more about what that means. You have to ask that question. And studying statistics helps you learn how to ask those kinds of questions of data, right? So I have met a couple of people who said, nah, women aren't these people who are beaten up by the system, right? If you look at household violence, everyone messes up everybody. And really what they're trying to do is they're trying to hide behind, they have a belief about how men and women interact, that they are trying to hide behind data by saying, look, it's equal. It's equal. But if you look into the data, it is not equal. It is not equal. You just have to look into what do some of these definitions mean. And that's what I hope you can get out of this class too. So you can be less manipulated and have strong advantages in the workplace. That's why I think we should all care about stats on top of all the good that we can learn about science as a whole. Next big question, is it hard? Yeah, yeah. Studying statistics is often either it fits your brain very easily or it does not fit your brain very easily. There are some people who they're somewhere in the middle, but I keep finding with students that it is more often, yes, stats is very hard. But that's a good thing. That's a good thing. There is good research out there that you can find in the notes of this video and of this PowerPoint that prove that forcing your brain to think in mathematical ways, even though you don't like it, is going to turn into intelligence and strengthening your brain and strengthening your mind's ability to conquer problems in other areas too. So, is it hard? Absolutely. And you should still do it because it's like a workout for your brain that will then make it easier to use your brain in lots of new places and new situations later on. Now we're ready to get into some of the nitty-gritty and get started on talking about statistics. What is statistics, right? So we're going to start this section. It's going to be 2 slides. There's going to be a lot of words on these slides. I'm apologizing ahead of time, but we're going to work through these slides pretty slowly. So first of all, what is data? What the heck is data? Data is a point of information, just a little bit, right? And if you get enough data, enough points of information, right, it can tell you a lot about it gives you a picture, right? It tells you a lot about what's happening in a situation, in a reality, right? So for example, if you're in charge of like a Toyota plant and you have employees who are trying to like work on the line, on the assembly line, right? You need a lot of bits of data, especially when 1 month suddenly everyone on the line is producing half as much as they usually do, right? Yeah, if you're like, well, I want to find out what's going on, you could ask one employee what's going on, Are you having a good day? That's one question. So that's one bit of data from one employee, one small bit of information, right? And you can think of that one small bit of information like a pixel on a screen, like one little light bulb or one dot of ink on a page. Um, and if you ask enough people enough questions, you get enough of these dots. They have all different colors and shades, and eventually you get a big bright picture that tells you, the restaurant or the fast food place or the way they did lunch changed suddenly. Like if they all went to Chick-fil-A for lunch and that Chick-fil-A closed, well, now they have to go further to get lunch, or they don't pack lunches and now they're all getting exhausted sooner, and that tells me my assembly line of workers needs more support, needs a different kind of lunch regimen. So that's data. Data describes complex situations, one variable at a time, one piece of information at a time. And we're going to talk about what a variable is very soon, too. So another thing to know about statistics is statistics, if you have enough points of data, right, you can actually start looking not just at this present moment, but into the future, and look at probability of events upcoming. After you have a couple of different variables measured out, you can compare those two to each other. So as one variable moves, the other variable moves too, and you can then start making predictions about the future. You can start making predictions about the future. For example, if you know that as temperatures rise, people like to swim more, right? Well, what do you need for swimming? You need swimsuits, you need swim goggles, you need flip-flops, you need the whole kit kat and caboodle. Swim gear, you need summer gear, right? Then you know that as temperatures rise, this desire for buying this stuff goes up too. So then you know you can predict, hey, in the next month, temperatures are going to rise. We can probably sell more swim trunks in the future, in that next month, and we can get ready for that. And the word I used was we can probably sell more swim gear next month, right? So that's probability, that's likelihood of events. After you know one variable, and you know that this variable is connected to this variable, you know that this one might change, you can guess that this one might change too. And it works in the reverse as well, right? So if I know that having more restaurants in one spot actually makes it harder to sell more, then I know that if there are more restaurants, I'm going to see fewer sales if I put a new restaurant there. So the higher the level of restaurants, the lower the likelihood of me making money there. So I'm going to find a new spot to put a restaurant, something like that. So statistics describes a situation. We call it descriptive statistics. Fancy. And then we have likelihood of events or probability or inferencing. We're making an inference about what causes what. Inferential statistics. Descriptive statistics, inferential statistics. But you'll notice that over and over I said you have to measure data. You have to measure data. You have to know how one variable interacts with another. Well, how do you know? Well, you have to measure them, right? So we have this concept called levels of measurement. And we're going to work through, and it's right here on this picture, and we're going to work through from the bottom up. So there's four major kinds of data out there, four major kinds of data. We're going to start with nominal data. Nominal is another way of saying named data. It's just, that's all that data means. When I have a piece of nominal data, all I have is a name. One's not better than another, one's not higher or lower to another, they're just named differently. It's literally comparing apples and oranges. You can't, right? I can have 10 apples and 1 orange, but who cares, right? Because if I wanted an orange, it doesn't matter how many apples I have, I needed an orange. So they don't relate very strongly to each other. It's just a way of naming data, So if I went on the street and asked everyone, what's your favorite movie, right? That's nominal data, right? I would need other ways of measuring what movie's better or worse to in that situation. Just having a name of a movie is the just the basest level of data. It doesn't tell you a whole lot, but it can tell you something. Can tell you something. The next rank up we have is ordinal data. Ordinal data. So this is ordered. This is ordered, but it's not necessarily like we know the distance between two pieces. For example, let's talk about people racing, like in track, right? You can say first, second, third, and fourth place, but you don't know if the person who, like, the distance between first and second place could be like 100th of a second. They're very close, but the distance between second and third place could be like 5 seconds. So not even 1 second to 5 seconds, even though this is 1 to 2 and 2 to 3, the distances are all over the place. So it does tell you something, right? It does tell you that this came first, this came second. It gives you an order of events. But it doesn't tell you by how much. It doesn't tell you by how much. If someone got an A in a class and someone got a B in a class, that's great, but it doesn't tell you what percentage they got. The person who got a B might have been really close to that A, or they could have been really close to a C. You don't know. We don't know. But ordinal data is that ordered first, second, third kind of situation, right? So it tells us more than nominal data, but not a whole lot yet. Then we have interval data. Interval data is very specific sizes of intervals between each thing, right? 1 inch to 2 inch to 3 inch to 4 inch. Those are the same distances. The difference between interval data and ratio data, though, we're going to get to in a bit, is that absolute zero. Absolute zero. So for interval data, you'll see that some of the examples they have is temperature in Fahrenheit, or how you scored on an SAT exam, something like that. If your score on an SAT was, I don't know, 1100 and the next person got 1099, that interval of 1 point is the same as someone who got 1100 or 1099 and 1098. That 1 point is 1 point. It's the same distance no matter how you order it. Or if we go back to that race example, say someone came in first, second, third, and fourth, right? But we do have, now we've measured it by time. This took this person 12 seconds to finish the race. It took this person 15 seconds. It took this person 17 seconds, right? So we know that the distance and time is consistent. It's consistent all the way through. Even though the ordering might not be consistent, the interval data is consistent. Now, the only difference between interval data and ratio data is absolute zero. That's it. So you can have someone who is absolutely like they haven't done something before, they haven't reached a certain age, right? So you can't really compare like the drinking ages of a 20-year-old and a 12-year-old, because 12-year-old isn't the right age yet. That's illegal. But you can compare the drinking ages or the drinking frequency of someone who's 30 and 40. There's a 10-year difference with an absolute zero. Or how much someone spends in a certain week, right? If you look at, hey, how much money did you spend this week on subscriptions? Well, some people will say absolutely none. And other people will say, oh, like $1,000, right? And $1 to $2 is an interval, but it also has an absolute zero option. So nominal, ordinal, interval, ratio. Name only, nominal. Ordinal is making an order of events. Interval has consistent intervals between each level of, of measurement. And ratio is the same as interval except with an absolute zero. So now that we have some basics of what stats can do and how to order or understand data, let's also talk about what that data is looking at. Variables, values, scores. 1, 2, 3 different terms that I want to look at and how they're similar but very different at the same time. So let's start with the word variable. Variable are the things that you're trying to measure, right? They can vary in their results, which means that's why they're called variables. So if I wanted to measure, if I wanted to understand how shoes or shoe size affects golfing ability, right? My two variables are shoe size and golfing performance, right? Those are the things that they vary and they change. Obviously, what kind of shoes or shoe size can change person to person. And also performance of golf can change based on like how well they hit their swings, how well they putt, things like that. So because those results can vary, they are the variables. They are the thing I'm trying to measure. They're the thing I'm trying to understand. Variable, right? This is different than the word value. Values are the possible results that a variable can have, right? So when it comes to that shoe size and golf example again, when it comes, the values there are, well, shoe sizes would be, let's start at 7, 7.5, 8, 8.5, 9, 9.5, 10, 10.5. These are all the kinds of shoe options that are available to golfers. What is not available is things like tasty and yummy, right? Right? Because those values aren't possible with shoes, I hope. Some people might be eating shoes. Not to be measured right now. So values are the different possible results that you can get from a variable, right? We looked at shoes. We can also look at golfing performance. Someone could have par, birdie. Someone could go beyond their normal swing count, but they can't have red or blue. It tells me nothing. That's not a possible result. If I go golfing and someone tells me, how did you do? And I answer red, that is not a possible result for that variable. Does that make sense? The values are all the possibilities that a variable could have, right? Temperature can't be up or down. Fruit can't be 1 through 6. So values are the options the variable has. The score is the actual result given by an actual data point, right? If someone was to ask me, hey, how did you do on golfing? I would say, well, I had like a +4 on every hole because I'm actually quite bad at golfing. And that would be my actual result, right? That is my score. It's not the possible scores, it's the actual score that I got for golfing that day in size 48 shoes. Which makes me much worse at golfing in the first place. Below this, you can see that I've got a table here. And you can see that there's a couple of different like statements, and then there's some numbers on the side, right? So one statement here is, I feel good about my job. Right, and then there's 1, 2, 3, 4, 5. Strongly disagree all the way up to strongly agree. Those numbers, 1, 2, 3, 4, and 5, those are all the possible results that someone could give. Those are the values. Those are the values, right? And looking at some of these statements, I feel good at my job, I get along well with others at work. Take a moment, I'm going to pause for a moment. You take a moment and ask yourself, what is the variable that this is trying to study? What is the variable that this is trying to study? I do mean it. Give it a shot. Write it down somewhere if you want. The answer is job satisfaction, right? They want to know if people are satisfied at their job, right? So they can, the variable job satisfaction is being measured with the possible values, agree, disagree, to some of these statements. And these statements are also values in a way. But until you get a report back from somebody, you don't have a score. Now, if I were to fill this out and circle some of these numbers, then you have a score. I feel good about my job. Someone's specific score would be a 1 or a 2 or a 3. It wouldn't be multiple. It would just be one from that list. So remember, we're trying to separate out that these terms, variables, values, scores. Variables, the thing we're measuring. Values, the possible answers for that variable. And a score is a specific piece of data, right? Go ahead and ask yourself the question, what kind of data is this? Is this nominal, or is this ordinal, or is this interval, or is this ratio data, right? This 1, 2, 3, 4, 5, agree to disagree. Is it name only? Does it have ordered structure? Does it have very specific intervals between each option that we know the distances between? And does it have an absolute zero? Well, there's no absolute zero, so it's not ratio. It's not in name only because there is this ordered 1, 2, 3, 4, 5 kind of range, so it's not nominal. It's either interval or ordinal data. So the next question we ask is, if someone says somewhat agree and someone else says strongly agree, do we really know the distance between those two numbers, right? Do we really know how far someone agrees somewhat versus agrees strongly, right? And we can't really say we do. So because we don't know the interval distance specifically, it's going to fall under ordinal data. So it's level 2 data, ordinal data. All right, that's all I've got for our lecture today. There's another video right after this one for your labs, mostly going to make sure that we downloaded JASP correctly. And also make sure that you hit those flashcards for the other terms that I did not cover in today's lecture. I can't wait to see you guys again. Take care. Bye.